Alright, today we're going to talk about the properties of water, which is located in section A4 of your textbook. Unit 4's big question is, what caused the fish kill in the Snake River? Well, there must be something about the water. After this lesson, you should be able to answer these questions. What are the basic properties of water? Why is water so different than substances with similar molar masses? Why does a water molecule look like? What type of bond holds together the oxygen and each hydrogen in a water molecule? Why does oxygen have a greater attraction for shared electrons than each hydrogen? What factor determines oxygen's electronegativity? What does unequal sharing of electrons do to the electrical charge of oxygen and the two hydrogens in the water molecule? How do these polar bonds inside of a water molecule affect the interaction between multiple water molecules? How does the polarity of water molecule affect the intermolecular forces acting between water molecules? And how do hydrogen bonds affect the following: density of water, state of water, melting point of water, and boiling point? You need to know these definitions ahead of time before you start this lesson. Water is a form of matter. Water has many physical properties. We will discuss today density, state of matter, melting point, boiling point, and polarity. Later, we're going to be discussing terms like viscosity, surface tension, and solubility, but you don't need to know that today. So what is density? Density is defined by the amount of mass per volume, and it has units of grams per milliliter. The density of liquid water equals 1 gram per milliliter. The density of solid water, however, has a density of 0.97 grams per milliliter. This is the reason why ice floats, because it has a lesser density than liquid water. The different states of matter. Well, there's solid, there's liquid, and there's gas. And water changes states of matter through different ways. When solids melt, it turns into liquid, and when liquids evaporate, they turn into gas. When gases condense, they turn into liquid, and when liquids freeze, they turn into a solid. Solids can go straight to a gas through the process of sublimation and vice versa. When gases turn into solids, it's called deposition. The melting point is when the solid turns into a liquid, and the boiling point is where the liquid turns into a gas. Water has very specific melting points and boiling points. The melting point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. So why is water so different? If we take a look at similar chemicals that have similar molar masses, why do these have such different melting points and boiling points? Well, it all has to do with this idea that water molecules are very, very unique. They share electrons, and when they share electrons, this is called a covalent bond. However, oxygen has a greater attraction for the shared electrons than the hydrogen does. Thus, the electrons like to hang out with oxygen a little bit more often. Oxygen actually has a greater attraction than the shared pair of electrons than hydrogen does. So how do we know? Well, we need to look at what we call the atom's electronegativity. And by definition, electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons. So how to determine electronegativity? Electronegativity is affected by two factors. One, the atomic number of the atom, which equals the number of protons in the nucleus. More protons, higher electronegativity, because those positive charges are attracting the negatives of the electrons. The second one is atomic radius. The larger the radius, that means the valence electrons are further away from the nucleus, the weaker the attraction to the positive charge of the protons in the nucleus. So as we go from left to right, so as you can see here, here's hydrogen. Okay, it's got an electron, only one electron and one proton, and oxygen has 8 protons and 8 electrons. It's got more of a positive pull on those electrons from hydrogen. Okay? And when it has more pull, it's going to attract those electrons away from hydrogen. Here's the trends in electronegativity. As we go up a group, the electronegativity increases. As we go across a group, a row or a period, the electronegativity increases as well. So as you can see here, here's oxygen. It has a higher electronegativity than hydrogen. Therefore, it's going to attract those electrons when in a compound. This causes an unequal sharing of electrons in the water molecule. Will the oxygen atom have the same charge as each of the hydrogen atoms? The answer is no. So the bonds between the oxygen and the two hydrogens in the water molecule are really covalent bonds between the atoms that differ in electronegativity. The shared electrons are pulled closer to the more electronegative atom of oxygen, making it slightly negative, and the other atom, hydrogen, is slightly positive. This is what we call a polar bond, meaning it's got a positive side and a negative side. The positive side is where the hydrogens are. The negative side is where the oxygen is, because it is pulling the electrons away from the hydrogens. Here's a little simulation. As you can see here, these water molecules are being attracted to one another, and that's what's happening here with these little lines, because the negative from one atom is being attracted to the positive end of another water molecule. These are what we call intermolecular forces. You'll find out later that these are called hydrogen bonds, and they're temporary. So, how do polar bonds affect how water molecules interact with each other? Well, by definition, polar molecules are when there's an unequal distribution of charge, resulting in a molecule having a positive end and a negative end. This will cause intermolecular forces. As you saw in that little simulation, those little dotted lines were intermolecular forces, where these molecules are being attracted to one another because of the positive and negative ends of different molecules. So by definition, intermolecular forces are attractive forces between molecules that influence many physical properties. Because water molecules are very polar, they display unusually strong intermolecular forces also known as hydrogen bonds. So in that simulation you saw, the little dotted lines were called hydrogen bonds, and that is a type of intermolecular force. So what is a hydrogen bond? By definition, it's a type of intermolecular force that occurs between the hydrogen atom of one molecule and a highly electronegative atom of another molecule. In water, it's oxygen. Because of these strong attractions among molecules, a large quantity of energy is required to pull the molecules within the solid apart to form a liquid. This results in a very high melting point compared to similar molecule substances. The reason why the others, when we look back on that chart with similar molar masses, this is due to the fact that they have weaker intermolecular forces, and therefore their melting points and boiling points are going to be a lot less. Because water has a strong intermolecular force, this causes them to have a strong attraction amongst the molecules, making it very difficult to pull them apart. Therefore, it's very difficult and requires an enormous amount of energy to melt water as well as to boil water. Another consequence of these strong intermolecular forces is that these water molecules have strong cohesive forces. That means that they attract the molecules of water in the liquid have an attraction for one another. These strong cohesive forces are responsible for the water's high boiling point compared to other substances. Hydrogen bond is also responsible for the low density of ice compared to liquid water. When water freezes to form a solid, it takes on a hexagonal structure that maximizes the number of hydrogen bonds that it can form. This hexagonal structure causes the density to change because the molecules are spread out. Therefore, if they're spread out, they have lower densities, and thus ice floats.